Hey guys, welcome back to the Real Hacker Hours podcast. This is a podcast where I basically just record the normal side project work I typically do. It's been a while, took me a bit of a break, but I'm back. My new side project, what I'm doing is I'm effectively going through Nightmare and porting it over from Python 2 to Python 3. For that, what that will involve is I'm basically going through each, let's see. Here is a list of all the different sections of Nightmare. I'm just going through each one, of course, porting the exploit over from Python 2 to Python 3. But I'm also taking a look through the actual submodule itself to see, oh hey, do I use Python in other ways and import those things? And also just once over the submodule just to make sure everything makes sense because I've made a lot of typos while making this. But yeah, without further ado, the one I'm going to be working on now is Tamu 19.1. This is the exploit script, and this is the write-up for it. I'm just going to go ahead, pause the stream, and just spell check this real quick. Okay, cool. I ran it through the spell check, so let's start reading it to make sense. Take a look at the binary, pwn1. Let's make sure that that is still accurate. Tamu 19, file pwn1, pwn check sec pwn1. Oh, this is the 32-bit binary. I just realized I don't have the packages installed to run a 32-bit binary on a 64-bit system. I'm gonna pause it while I Google for those. Yeah, this is a brand new VM, so don't have that set up yet. Okay, so installed the packages. Just for a recap, ran that command, update, then install those packages, and it can run it just fine. See here, I'll give some output, we give it input, it says I don't know that. Cool, when we compare this to this, no canary found, full row, nx enabled, pi enabled. Yeah, seems about right. Cool. So let's move on. So you can see there's a 32-bit binary with variable, non-executable stack, and pi. Checks out. This binary mitigation might be discussed later. We can see that when we run the binary, it prompts us for input and prints up some text. When you take a look at the main function, you see this. So this is the decompilation of the binary in Ghidra. What is your request? This is where it gets. Okay. Briefly looking at this main function, we can see here first says stop, who would cross this bridge, blah blah blah. Scans an input, compares it to Sir Lancelot of Camelot, so you probably have to send that string first. Yeah, it does a comparison there. If it doesn't, then it exits. Then it asks basically the same thing, but it prompts with the input to seek the Holy Grail. Then calls get. Okay. With reference to one of the greatest movies ever. Yes, Monty Python and Holy Grail is a pretty great movie. You can see that we'll scan input into input using fget. Yeah, that checks out. That compares our input with string compare. Yep. The first time it checks if it, for the string Sir Lancelot of Camelot, which yeah, that checks on the second time. It checks for the string to seek the Holy Grail. Yep, that checks out. If we don't pass the check the first time, it will print I don't know that. Yeah, that checks out. And exit for the second check if you pass it. The code will call the function gets with input as an argument. The function gets will scan in data until either, yep, that checks out as well. I'll paper this now. Since the area it is scanning into is finite, this will be able to overflow it and start overwriting subsequent things in memory. Yeah, that checks out. Also looking at this in the code around gets, we see that there's interesting that the decompiled code doesn't show us. Oh, okay. So Okay, this assembly. I was kind of wondering, like, since the purpose of this module is like overriding variables, looking at this decompiled code directly, we don't see anything way that we can like overwrite a variable to get code execution, but we see here there is a comparison followed by a function to print the flag, so we can see that it compares the contents of local 18 to this hex value, and if it's equal, which means it's 0. Oh, means if it's 0, um the compare instruction. Since the compare instruction effectively just it substitutes one value from the other. If it calls the print flag function, look at the decompiled code for print flag, we see that it just prints the contents of flag.txt. Okay, cool. So effectively looking at this, if the local 18 variable is equal to this hex value, it will print the flag, and we can do that using the gets buffer overflow. So we just need to figure out the offset, and then we have solved the challenge. Should get the flag that's the same. So in order to do this, we look at the script, layout, and keystrokes, collecting the variables, and the variable declaration shows us the offset between our input and local 18. Input is at -43. Local 18 is at -18, so it should be at not -43, 43 bytes, which is 2b, which that matches this between the start of input. Then we can just overflow it and overwrite. Putting it all together, get the following exploit. And yeah, okay, so that checks out. So it looks like the only thing we'll really have to do here is just port this over to Python3. For that, here's the exploit right here. One thing I'm going to do is we see here that from Python we're using process P32. So I'm just going to go ahead, instead of doing from Python import, all I'm going to do from Python import process and P32. That way we aren't importing the entire library of Python, just those two things. From the purpose of just like a simple exploit script, it really won't matter too much, but it's a good coding practice, so why not? What else do we need? Oh, because this is Python 3, this will need to be a bytes array instead of strings, so we just have that, and that, sunlight. This will need to be bytes. And looking over this, yeah, it looks like that should work. Let's try it. And yeah, we see that got flag. Got 'em, boys. So, which, let's just double check. Yep, that is the flag. Cool. And we see that we get it from Python 3, so let's just go ahead, copy that there. And let's copy this. And yeah, that one has been ported. Cool. I'm going to go mark this as ported. Cool. So the next one in this module is Tokyo Western's Just Do It. So let's take a look at that one. I'm going to close out of this one first. Western's Just Do It. Okay, let's take a look. 32-bit elf. Okay, with those mitigations, and we run it. So let's go over and take a look at it. So the binary mitigations and the file type match, so it wasn't like the file got swapped out. One thing we do see here is when you run it here, it says no such file or error, but here when you run it, it says it actually gives us the proper output. That's because, as you see here, so it's complaining about a file opening error. Yeah, it's looking for a file, and if it can't read it, outputs an error. Yeah, flag.txt. You can also see the binary such property for input, and if it's the right password, print out logged in message. If no, print authentication error. Password. Okay, so it asks you for a password. Okay. Be appended to the end so to pass the check. Okay, so we see here that we can pass the check. However, that won't solve the challenge. We also see here there's a bit of Python 2 code that I will need to port, but I'm just going to go through the module real quick just to make sure it makes sense. Yeah, so looking at this code right here, we can see that it will do a scan an input, compare it against the password, which is a defined string. If it is successful, it will set target to a success message and print that. If not, I'm assuming target is set equal to target equals failed message. So by default, it's failed message. Either way, either print like you're logged in or you're not logged in. Either way, doesn't actually solve the challenge for us. If it's gone, we can see 30 bits of data scanned into phone buff. So 32 bits of data scanned into phone buff. Where does that happen? That happens here. 32 bytes OX20 scanned into vulnerable buffer. Vulnerable buff is OX28. Can hold. Next thing on it is OX18. So the difference between that is OX10. So we do have an OX10 or 16 byte overflow there. We have a buffer overflow. However, it appears that we can't reach the EIP register for RCE. However, we can reach target, which is printed with a puts call right before. So we can print whatever. Oh, okay, so effectively what's going on here, we get to scan an OX20 bytes into vulnbuff. That would give us all the way up to, since we start at minus OX28, that will bring us all the way to minus OX8. We see here there is target, which is a char pointer stored on the stack, is stored at offset negative OX14 and occupies those 4 bytes. So we can overwrite target, which is then printed here. And let's see, stream. We see here tries to open this file. It will then scan it into flag, which, if I recall correctly from doing this years ago, flag is a char pointer that's stored in the BSS. Yes, it is. It's stored at this static address. So effectively, at this address in the BSS, the flag contents is scanned in, so we can just use this buffer overflow that occurs, where is it? Here, to overwrite target to point to that region, and then it gets printed with puts. Since puts, the function call takes in a single argument, which is a char pointer to the string it's going to print out. So then we see here Python 2, it just will go ahead and forgot the $sign there. 20 bytes worth of data, 14. Does that make sense? Yeah, it will be OX14 to get from minus OX20 to minus OX14, which is 20 bytes, so that checks out, so we can form a payload 20 null bytes, followed by the address of the flag. What is FGET? Oh yeah, so certain types of input functions, like scanf with a %s, they will not allow you to scan in null bytes, but fgets will. So let's do here. Okay, so here, yeah, the payload is just 20 bytes until we reach that char pointer, which you just overwrite with flag and least Indian. We see here a print in it. Here is the Python 2 script, and here is running it. So what will we need to have updated? We will need to do this exploit right here, and in addition to that, this right here will also need to be updated. But first, let's just do the exploit script, since that will be quicker. Now, one thing I've noticed with Python 3, at least for me, it's just easier just to quickly write a script than deal with the Python 3 one-liners because of how like some of the byte conversions work. So I'm just going to open up this. Let's just quickly port this over. Let's see what we actually need from here. We need process remote, even though it's commented out, kind of want to have that it imported, that way you can just uncomment this line and have it work. And P32, so let's do that. Process remote P32 import pwn-tools utils. This will need to be a bytes array. Should convert that to bytes. And yeah, that should do it. I'm just going to clean up these comments a little bit. Okay, cool. Let's see if this works. Python 3 exploit. Oh, yeah, I see. Python 3 print statements require the parentheses, which I've overlooked. Okay, we see here it was able to successfully run and exploit it. So I'm gonna actually. So this was a challenge that I solved during the live CTF, and this is the prompt that I got when I actually got the flag. I can tell that since it's actually opening connection to pwn1child.ctf.tokyo Westerns Tokyo, even though the team name is Tokyo Westerns. Kind of conflicted that I want to keep this, but oh well. I'm doing Python 3 now, so I'll have to change it. F in the chat. So let's copy that text. Oh, what's happening? Hang on a second. Okay, I'm back. Let's copy this. That's there. Okay, let's copy in the new Python 3 exploit. And I'm going to edit this text up here so that we only have the exploit. We don't have this Python one-liner, since this Python one-liner effectively does the same thing as this. So here we can see that the flag lives in the BSS with the address. That address, there are 20 bytes between phone, buff, and target. So you can form a payload 20 bytes followed by the address of flag. With this payload, we will be able to read the contents of flag.txt exploit. Let's run an exploit to use the same. Let's run an exploit to do this. And let's just make sure this makes sense logically. So here you can see the flag lives in the BSS with the address. Then there are 20 bytes worth of data between vuln, buff, and target. So you can form a payload with 20 bytes followed by the address of flag. With this payload, we'll be able to read the contents of flag.txt with our exploit. Let's write it and run it. Cool. So now we just need to port this over. I'm just going to write a quick Python3 script that does the same thing. This just prints password followed by a null byte. So all we have to do for this is going to remove the remote portion. Gonna remove this. Going to have it send, what was the string? Password with a null byte. So we can just copy this, paste it here. Okay. Create. Establish target process. What is the next one? Print out the starting prompt. What is this? Send the password and I'm gonna edit this comment to change it from the server prints out to the binary since we're not. When I initially wrote this or solved this, it was during the CTF. So in a CTF, a server will be running the challenge and you actually will run the exploit against the server. Now, yeah, since now I'm just running the binary locally, I'm just going to change the comments to make logical sense with that. So we have this. Here's some. So this is going to be the Python3 code to do that. This is going to be us actually running it. Oh, what did I just do? I overwrote the exploit. Luckily, I had a copy right here for my smooth brain. This will be named password.py. And we can see here the purpose of this was to get the correct password, which we're able to. Here is some Python3 code to accomplish that. When we run it, we see that we have successfully authenticated. And then we can just delete this Python2 part because those two Python3 parts do the same thing. And yeah, so we went through this, replaced all the Python2 with Python3 and made sure that the solution makes logical sense. With that, this is done. So we did those two submodules, and I did the seesaw one yesterday. So this entire one is ported. So I'm going to go ahead and cut the video here for now. We ported over two of them. Thanks for watching. I'm back from break, so I'm going to be posting a lot more. See you guys later.